Hello and welcome to homework help for lesson 6.3, Exponential Growth and Decay. Today we'll be doing two problems from the homework, number 1 and number 3. So as always, before we jump into the homework help, let's start with a recap of our basics. So on the left, I have a function f of x defined as 2 to the power of x. On the right side, I have a different function, 1/2 to the power of x. Now, the only difference between my functions is the base. That's what we call this guy underneath the exponent, is the base. So on the left, I have a base of 2, on the right, a base of 1/2. And that is going to make all the difference. Let's do let's plug in some points for x and see what we get for our graphs. So on the left side, I'm going to plug in -2. So I'm looking right here. I'm going to plug in -2 for x. So 2 to the -2 power is really, remember, negative exponent means take the reciprocal of the base. Basically, since my base was 2, technically like that's 2 over 1, the reciprocal would be 1 over 2. And so this is equivalent. 2 to the -2 is the same as 1/2 to the power of positive 2, which is 1/4. Okay, now I'm going to do the same thing with the power of -1. So, first let's plot that point. At -2, we had positive 1/4, barely above the x-axis. Next, I'm going to go ahead and plug in -1 for x. So 2 to the -1 is really 1 over 2 to the power of positive 1, which is just 1/2. And so at -1, I'm slightly higher than the previous point. Now, a property that you should be familiar with, anytime you take something to the 0 exponent, 2 to the 0, that's always going to be 1. Actually, we should probably write that down in our notes. This is a rule. Whether it's 5 to the 0, 10 to the 0, -16 to the 0, it's always equal to 1. So we can plot that. At 0, I had 1. And we'll keep going. 2 to the 1 power will give me 2. And then 2 squared will give me 4. So all I did was I plugged in these x values into my function for x. And I just wanted to see how my graph responds. So at 1, I got this point 2. And then when x was 2, my height was 4. So what you'll notice as we keep going, if I plug in 3, 2 cubed will give me 8. If I plug in 4, I'm going to double yet again. From 8, it'll become 16. And then the next value will be 32. Notice the pattern here. Every time I moved up, every time I increased my x by 1, these values doubled. That's called the exponential factor. The fact that every time I moved up one value on x, my graph doubled. So my exponential factor is 2. And that's really just the base. Okay, so when you see the word exponential factor, that just means the base. Okay, so let's connect these dots and we'll see that we have a rapid growth here. This is called exponential growth function. And it always has that basic shape. Okay, now let's go ahead on the right side and see what happens with g of x. Again, the only difference is that it has a base of 1/2. So if we take 1/2 to the -2 power, I'm plugging in my x values to see what happens with y. Well, that means take the reciprocal of the inside, so it'll be 2 over 1 to the power of positive 2, which is just 4. We'll do the same thing now with our next x value. Let's plot that point. It was at -2, 4. Now I'm going to plug in -1. So -1/2 to the -1 gives me 2 to the positive 1, which is just 2. So when x was -1, y was 2. And as we discovered last time, anything to the 0 power is just 1. Next, I'm going to plug in x to be 1, so 1/2 to the power of 1 is just 1/2. And then 1/2 squared is 1/4. And you'll notice the exact reverse shape as the last graph. This time, we have an exponential decay function. And so what I want you to take away from this lesson is just this. Not all these plotting points. The plotting points is just what we do to see the shape of the graph for the very first time. But please understand this. The basic shape of the graph, which is either it's growing or it's decaying, is going to be determined by this number, the base. So here's what I need you to understand. When we're given an exponential function that looks like this, it could have some number being multiplied. It could look like this or like this. That number being multiplied out in front does not affect the way that the graph looks, or its basic shape anyway. But what we are interested in is this base, okay? So if the base is less than 1, then we have a decay function. Remember up top, we had this function, 1/2 to the x, and that was decay. If the base is greater than 1, then our graph will be growth. So it will keep on growing. So for example, here, 3 to the power of x, that has an exponential factor of 3. So that means it's going to keep tripling and tripling and tripling. If I have 5 to the x with the 1/2 being multiplied, that 1/2 is not what I'm interested in. It's the base of the exponent. So this has an exponential factor of 5. It's going to keep multiplying by 5 every time. And so these are both going to be growth. But then this one right here would be a decay because the base is less than 1. That's all you got to know. Now, I do have one warning. I need you to watch out for negative exponents. Because negative exponents have this tricky little feature, right? Where they take the reciprocal of the inside. So, for example, if you look at this function here, our base looks like it's 5. So you might be tempted to classify this as growth because 5 is greater than 1. But you have to rewrite it but you're going to have to be careful with these because the negative exponent means that we need to actually rewrite this as 2 times not 5 to the negative x, but 1/5 to the power of x. If you have a negative exponent, you must rewrite the function and take the reciprocal of the inside. So as you can see, my base is now less than 1. This is actually decay. Let's look at the second example. Okay, we have a negative exponent. That means we've got to rewrite our base, take its reciprocal. So instead of 0.3 times 1/4, I actually have 0.3 times 4/1, which is just 4 to the power of x. And now my base is greater than 1. That makes this a growth function. Let's look at this final example here. We have a negative exponent, so we've got to rewrite it. So that'll be y equals 4 times, not 3/2, but 2/3 to the power of x. And that means, well, 2/3 is less than 1, right? Because 3 doesn't go into 2, not even once. So this is going to be a decay function. So again, we're always interested in the base. Generally, if the base is less than 1, you'll have a decay graph. If it's greater than 1, you'll be growth. But watch out and rewrite when you have negative exponents entering the equation. All right, let's do the homework. For problem number 1, D, we're to identify growth or decay. So, do not be distracted by this number out in front. That number does not affect the basic shape of my graph. I'm interested in the base. Okay, 8 over 3. Well, 3 goes into 8 2 times-ish. So this is definitely greater than 1. It's approximately like 2.66. Since my base is greater than 1, actually I'll do it in green. Since my base is greater than 1, this is growth. My exponential factor is the base itself, which is 8 over 3. And now to find a y-intercept, we always set x equal to 0. So y-intercept is a point that takes the form 0, comma something. We're going to find the y-intercept by setting x equal to 0 and solving. So remember, we just talked about this. Anything to the 0 power is 1. So I have 0.1 times this expression, which just became 1. And 0.1 times 1 is just 0.1. So my y-intercept is the point 0, because that's what I plugged in for x, 0, 0.1. So if I wanted to quickly sketch this graph, all I need is to go to 0, 0.1, and then draw a growth curve through that point. So remember, you start low, and then you end up going high. That's what it means to grow. From left to right, low to high. Okay, let's do our next example. So, for letter E, we're looking at the base. My base is 4, but we have a negative exponent. That means we have to rewrite this. That'll be 3, our base won't be 4, but it'll be 1 over 4 to the power of x. Aha! So, this is less than 1. Since my base is less than 1, this is decay. My exponential factor is actually 1/4. And then my y-intercept will always set x equal to 0. So let's see what we get. 3 times 4 to the negative 0. Or, actually I could just plug it into my rewritten function, 1/4 to the 0. So anything to the 0 is just 1. So that's 3 times 1. And 3 times 1 is 3. My y-intercept, therefore, is 0, 3. And here's my quick sketch of this graph. Go to 0, 3. And you're drawing a decay function. That means on the left, you're starting high, and then you get increasingly small without touching the horizontal asymptote. Now for F. Growth or decay? Before we answer that question, we've got to rewrite this. 3 times. So instead of e, we really have a base of 1 over e to the x. So you may recall from class, e is just a number like pi. It just stands for 2.72 approximately. And, well, if originally e to the x, a base of approximately 2.72 to the x, this would be growth. But since we have 1 over 2.72, it turns into decay. This is a decay graph. Our exponential factor is actually 1 over e. And our y-intercept, we'll set our x equal to 0, is 3 times 1 over e to the 0. Now using your order of operations, we first do our exponents. So anything to the 0 power gives me 1. And then multiplying by that 3 out in front, I get 3. So our y-intercept is 0, 3. Here's my quick sketch. 1, 2, 3. And we have a decay function. So start on the left and then go high to low. All right, next problem. So for these, we're just asked to identify growth or decay. So again, we're looking at the base, except when we have a negative exponent. Look ahead, where are our negative exponents? There they are. we're going to have to rewrite those and then look at our new base. So let's rewrite these. That's going to be f of x equals 5 times 2 to the x. And this one would be rewritten as 2 times, instead of 5, which is 5 over 1, I'm dealing with 1/5 to the x. Now these guys are good to go because there's no negative exponent, so they're easily identified. So let's start at the top. Growth or decay? My base is greater than 1, so growth. Okay, done. Next one, growth or decay? Well, 7 doesn't go into 2. 2/7 is less than 1, therefore decay. Next example, 4 to the x. It's almost too easy. My base is greater than 1, and so this is growth. Finally, we're actually looking at this guy right here. My base is 1/5, which is less than 1, therefore decay. I hope that was helpful for you, and I'll see you next time.